Good morning, everybody. Today we are going to show you people how we are using our tools and how to prepare an intervention or anything concerning our BTS site, any work that you are going to do at BTS site. First, we need all this material. We have current tester. This is to test the power supply of the AC current. If you test, if available, you will see the red light on this bulb. Okay, the same process with this one. Here, this is the multimeter. We use the multimeter to test the current. This is the current transfer to test the current on the line, on the electrical cable. And you have many other options. As you know, this is the multimeter. You can test current, you test voltage, DC voltage and AC voltage. You can test the resistance value of some equipment. You can test even the continuity of the cable. You test the temperature and the capacitance of the device. Now,
frequency.
You can also use it to test the frequency. And this one, it depends on the capacity of the multimeter, because all the multimeter cannot test the frequency of the power supply. Now, we need a shifting spanner, a monkey wrench. This is called monkey wrench. You can use it for fast tightening or fast loosening, to loosen a bolt or any other device. You can use it on the V5, AC V5, use it on the DC cabinet, on the rack, when mounting or dismounting the rack at BTS site. This one are the spanners. We need these spanners to loosen and tight any bolt at BTS site. On some bolt like this one, you use the flat or ring spanner. These are the spanners. We need this spanner, this set of spanners from spanner 8 to spanner 24, according to the uses that you are going to the work that you are going to do at BTS site. Now we have screwdriver. This is the star screwdriver, and this one is the flat screwdriver. So star and flat, we need two of them when you are going for intervention. Here you have a set of screwdriver head screwdrivers. This one is just the hand to mount the head and use it. We need all this set when going to the site. As I talked very early, we need a small monkey wrench, not monkey wrench, small, yes, monkey wrench, small monkey wrench for different heads like this one. These pliers is used for very a big bowl that cannot be loosened with small strength, with small force. We use it and block on the bowl before loosening it or before tight it. And you also use on the pipe for pipes, small pipes. This is the brush to clean rectifiers. when you are going to the site, you know, every 3 months you have to dismount rectifier and clean. We disconnect the rectifier, dismounting it, and brush, remove the dust inside the rectifier. This is to clean the surface. It's a toilet roll you can use to clean the out area surface, to clean even the rectifier, the DC cabinet, the ACV5. These are ties. Is to arrange the cable and tie them against wind. You know, when you mount the cable from the RRU to the indoor unit device, you have to tie them fine on the climb. If not, the wind can vibrate the cable maybe and create some disconnection on the cable. This is slow tape. We use this electrical PVC tape. This slow tape. When you arrange the cable, you put the head cable, you must protect it against the arc, the electrical shock, against short circuit or contact with the head or grounding system. This is a plier, cutter. We use it to cut the cable or any other thing outside. We are going to talk about the grid, our grid energy. First of all, we are going to talk about the eniometer. This box, you have 3 components that you have to check. The first is the energy meter, the eniometer. Here, you check if the display is still showing. If the display is good, you can read the index. The second device is the circuit breaker. When you come to the site, you have to check the status of the circuit breaker. When the black is on, is in, it means the circuit breaker is on, and our equipment are supposed to be supplied. When is the red in, that means our equipment are not supplied and the circuit breaker is off. When there is any short circuit, this circuit breaker is supposed to react and off the meter to protect our equipment. So you put the black one on, and the last one, the last device that you are going to check is the cable. This cable, as you can see, this cable is not well protected. The cable is not well protected. Any person can have electrical shock, which is not good. You can use slow tape to protect more than this. You use slow tape.
think that the first you must remove all sword.
Okay, this well protected and everything is okay at the level of the metal. Now the cable going to the BTS side, we must ensure that at the entrance of the container house, the cable is not supposed to be up like this, because when cable is up, when the cable at the entrance is up, it can drive water from out. It can drive water rain from out to indoor to inside the machine room. Another thing, we should try to check any contact of the cable with the fence and with the anti-volt system, because as you can see, this barbed wire, it can warm the cable and short circuit the phase and the neutral. So you should try to check each time that you reach to the side. Try to control the cable if the cable is still protected.
Check.
Now, after check the move, you have to check the GZ. The GZ is another device protecting our equipment. Now, to check the GZ, first of all, you switch off our meter, our electrical meter. So you come to the main circuit breaker of a new and shut it down, and press the red button to shut it down. After shutdown, we go to the ACV5 and check the GZ. We remove the cover. After removing the cover, you use multimeter to check the GZ value. You put our your multimeter at the ohmmeter parameter. Now with the ohmmeter you test.
Okay.
To check the GZ, first of all you have to check it physically. As you are seeing the GZ now, it's not broken. You look at the two terminals of the GZ, it's still good. Now when the GZ is still good like this physically, it does not mean that the GZ is completely good. You check now the value, the resistance value of the GZ. Checking the resistance value, you put your multimeter in the resistance parameter. When you put it at on the resistance parameter, you check on the two terminals the value of the GZ on the multimeter like this, and look at the value of the resistance showing on your multimeter. And this resistance is supposed to be infinitive. That means more than 10 mega ohm. When the resistance is more than 10 mega ohm like this, it means the GZ is good. It can protect our equipment. The second one, the same process. You check. You check it like this, and when you see OL, it means out of limit, because the value is more than the value that the multimeter can measure. Okay, these are the terminals to connect the AC grid and the generator power supply. As you can see here, this one is to connect the grid power from a new meter, and this other one, that means E and F, is to connect the generator, the supply from the generator. Now, the additional one, which is the emergency terminal to connect the generator, is this one, external. So you can use this one only for emergency case. You should never use these terminals to connect permanent generator at BTS site. Only mobile generator when the big generator is faulty. As you can see, these terminals are not well tightened, and if you connect the mobile gen or the big generator there, you will have electrical arcs who can produce short circuit, who can get burned, and so forth and so on. Okay, when you reach to the side, this is the ACV5. You check first of all the MOV. This is the MOV. How to check the MOV? This is the equipment. The MOV you have here, the glass with the color, red color. Now, to analyze if the MOV is still good, don't be surprised or don't misunderstand when you write here red replace. The color are red when the color is red, but there is some difference between light red and strong red. Now, as you are seeing the MOV, the red is very far inside. When this red comes closer to the glass, when it comes, because it's supposed at this level is still at 2 centimeters from this glass. When it comes closer to the glass, the MOV becomes bad and need to be replaced. You can leave it, it's still good and can continue to protect our device. Measure after finish checking of our GZ and the move, you cover back the ACV5 to protect any downfall of some device which can produce a short circuit in our ACV5. When you cover it like this, it's the end of the process to check our protective device, the SPD. And finally, when you finish to close and screw, put the screw back, and you have to clean the ACV5 to ensure that everything is well clean. Now we are going to talk about the DC cabinet. DC cabinet immersion. On the DC cabinet immersion, as you can see on the control unit, you have to analyze the display. You can see here float, which is 53.5 volt. That means the float voltage is 53.5. And you see 21.1 ampere, which is the current of the load. Actually, the current used by the load, by our equipment at BTS side. The system of the controller is the auto mode. we are using auto mode and the alarms. Now, to check, you can check the status. At this level, you can see how many alarms are active. Looking at on the light here, you can see red light. That means some alarms are active. Which the alarm active? You can enter the active alarm and see that you have save power on our rectifiers. Save power means we are using energy saving for our rectifiers, and you can look at the rectifiers. You see one rectifier running, the rectifier at the middle, two rectifiers on sleeping mode. That's why you see yellow light and the green light beside. That means the rectifier can run normally, but we have the sleep mode. Now we can go back to the status of how to check the rectifier. To check the rectifier, you have three lights on the rectifiers: the green light, the yellow light, and the red light when the rectifier is bad. The green light means the rectifier is okay, can work normally. The yellow light means the rectifier is on sleep mode, on energy saving mode. And the red light, which is not on now, you can have a red light, this one here. That means the rectifier is not good and need to be replaced. Okay, we are going to talk about the parameter. The parameter. The first parameter is status. The status, you enter and you see active alarm, rectifiers, history alarm. Active alarm, as you can see here, red light. It means one alarm is active. You can press enter to see what is the alarm on. The first, you have two alarms. The first alarm is save power. That's why you can see alarm 1 on 2. The second one is load fuse fail. That means all the fuse are not working at the same time. Load fuse 1. The first alarm is save power, and the second alarm load fuse fail. You go back to rectifier. On rectifiers, you can see all the parameters about the rectifier. The out volt, which is 53.5, the out current, which is 0, because now the rectifier are not taking current. The current limit 85%, the in volt 232, the AC state off, the DC state off, and the AC derated and the temperature derated, which is no, we are not using them. You go back to history alarms.
No.
Going to the rectifiers parameter, you can enter rectifier. The first line, you see you have 3 rectifiers. That's why you see here 1 rectifier on 2. That's the status of the first rectifier. And the current, the out current is 0. That's why the rectifier is on sleeping mode. First line 2 on 3. That means the second rectifier, the out current is 20.5 ampere. That's why the rectifier is still on. It's the only rectifier running. The third rectifier, the same like the first one, the same as the first one. The first one was on sleeping mode, the current was 0. As you can see, the out current is 0. That means the rectifier is on sleeping mode. And also, On the yellow light, you will see the fan of the rectifier off. When you have green light, only green light, you have the fan of the rectifier which is running. That's the difference and the status of the rectifier. How to check the rectifier? You look at the light, green, only green, like this one, green and yellow, sleeping mode, or red, that means the rectifier is bad, and you check that if there's no light, you can check at on the fan to see if the fan is running. If the fan is not running, that means the rectifier is damaged or the rectifier is not supplied. You have to check the supply of the rectifier. Go to maintenance setting. On the setting parameters, press. On the setting parameters, you have the first line: alarm setting, battery setting, AC setting, DC setting, rectifier setting, system setting, and common setting. Now, the first one, alarm setting, you can set and configure all the alarm level, the alarm control, and the DI setting. You can set also the battery setting. Okay, we are going to talk about the alarm setting, the first parameter. Alarm setting, when you enter alarm setting, we talk about the alarm level. In alarm level, you have alarm block. At this level, you just choose the relay that is going to be configured on the say alarm. Maybe you have alarm block. Alarm block, you choose SPD alarm. We don't use it. DC SPD, DC digital alarm. Battery fuse alarm, and change. When you reach at the level of LVD, you choose alarm 4, LVD 2, main failure, alarm 3. So alarm rectifier, contact relay 3, rectifier loss 3, system main no use, multi-reg. And this is for all the alarms that you are going to configure. You just have to look at your parameter book and configure all the alarm as required. Stop. Now the second parameter is battery setting. On battery setting, you choose basic setting. In basic setting, the system mode is auto. You have to put auto. And the second one is battery fuse. Battery fuse, we have two string of battery, two cable. That means you are using two strings. And the capacity, you put the total capacity of the battery that you are using. The total capacity according to the number of string, the total string. After you have battery shunt, you put yes. It's okay. Yeah. After basic setting, you have LVD setting. At LVD setting, you have LVD 1, LVD 2. LVD 1 is the LVD which switch will disconnect the non-priority load, and the LVD 2 disconnect the priority load. As you can see, you enable yes and yes for the two LVD 1 and LVD 2. The parameter of LVD 1 is 55 volts. The parameter of LVD 2 is 43.2 volts. which is battery
Normal side.
battery load BLVD, battery load voltage disconnected, and the first one LVD, which is load low voltage disconnected. Now this is for normal side. You have to remember that for main node side, the LVD is supposed to be 47.5 volt and the BLVD 45 volt.
42.
And
42.
I'm talking about the LVD. The LVD is supposed to be 47.5 volt and the BLVD 42 volt. And the low voltage, the battery low, is supposed to be 50 volt. After this, we go to the charge system. Charging system, you have the float level, the burst voltage. The float voltage is supposed to be less than burst voltage. Float voltage 53.5, burst 56.4, and the limit of charge, which is 0.10 C10.
10. That's not it. 10.
Now the temperature, you have 25 degree. This is the main and the temperature, the battery temperature, which is supposed to be 35 degrees Celsius.
Okay.
This is the limit. Okay, concerning AC setting, you have the third parameter, which is AC setting. You have three parameters to configure. The overvoltage, which is 280 volts, the low voltage, which is 180 volt, and the voltage, which is 80 volt. For the AC phases, you can put one phase or three phase. It depends on what you are using. It's the same. You cannot change about the parameters.
Okay. This is okay.
DC setting now, you have to set the overvolt 58.5 volt, the low voltage, which is 57.5 for normal side, and 50 volt for main node. The temperature in the machine room, which is 40 degrees. The fifth one is the rectifier setting. For rectifier setting, the position you don't use. You don't enable the position.
Only working time.
You don't have to configure the working time. The working time parameter is yes, and the working time is 128 seconds.
Or 1 day. If you have a 2 DC cabinets.
At the main node side, we have two DC cabinet. The two DC cabinet, you change the working time. The first DC cabinet, you put the working time 90 seconds, and the second one 128 seconds. And the last parameter is system setting. In the system setting, we are going to modify the parameter of the date. You modify the date, set the year, the month, and the date. Secondly, you set the time. What time is it now?
Stop the time with
The time, which is
the service.
the time with your watch or with your on your phone. You can look the time on your phone and set the parameter. Now it is 15. Now you change the parameter again and go to energy saving. The energy saving is to configure the rectifier. The save time you configure yes. The cycle is 168 hours. That means 1 week for the rectifier to change from the sleep mode to working mode, and the rectifier work is 80%. The limit of the rectifier on the sleep mode is 1. As you are seeing the batteries, you have to check the batteries, the quality of the connection. The battery is these are supposed to be well tightened, all the ball. All these balls are supposed to be well tight, and when you go to the side, you have to clean all the terminals of the battery. Clean it and check if there is any faulty contact and tight it well. Secondly, you check the cable, and all the cable, the blue cable and the black cable, are supposed to have the protector, the pipe, this pipe, to protect our cable, because you know DC is very dangerous in our DC cabinet. If at time you reach the site and discover that the bolt are not well tightened, you take the spanner and protect it. You have to cover the spanner well to avoid any short circuit on the terminals of the battery. When the spanner is well protected, you can use it now to tight all your terminals of all your battery terminals. Now we talk about the connection of the alarms. As you can see here is alarm 0, alarm 2, alarm 3 and alarm 4. We use alarm 2 for DC low, alarm 3 for high battery rectifier main failure, and alarm 4 for high battery temperature. And we use also alarm 3 for AC loss or loss of or main failure. Now we are going to show how to control alarms. I will start first of all with the alarm door, the door alarm. For the door alarm, to check it, you just have to open the door and close and see if you can receive the alarm on your mobile phone. For AC grid, you have the AC V1 alarm. AC V1, when the red light is on, it means the AC is on. When it's a generator alarm, when the generator is on, you have the red light here. And check also offing the grid. When you off the grid, you receive the alarm from on your phone. If not, the AC grid, the AC V1 will be faulty. you go and off your ionometer, come back and check the ACV one if the light disappear. For the same thing with the running generator, each alarm you must receive the alarm on your mobile phone to know if the alarm is working, if the contact with the alarm is working or not. Now concerning the fourth one, the smoke alarm. To check the smoke alarm is very simple. You just use the smoke. You can use
Okay.
to check. You have to install the smoke alarm on the AC cabinet or on the DC cabinet. And to check it, you install. You use the smoke to verify if the smoke sensor is working well, properly. And when you reach the site, you can also check by using the smoke on the smoke alarm on the smoke sensor and see if the sensor can react and you receive the alarm on your mobile phone. Now we are going to talk about the grounding system. The cable of the grounding system, yellow and green. We use that cable for AC, for all the AC equipment. We use the cable of 35 millimeter. For DC cabinet, we use the one for 25. And for equipment, transmission equipment, you can use a cable more than 14 or more than 16, 15 and above to protect our devices.
Wait.
Remember, AC V5, 35 millimeter, DC equipment, and AGG, all the DC equipment use 25 millimeter. Transmission equipment like Cisco is above 14 millimeter.
Okay.
As I said before, we use the ties to arrange our cables. You arrange the cables and tie them to straight the cable. Use the ties and use them as a connector. So you protect when finishing tightening the cable. You should not forget to cut the cables for good presentation. As you can see, like this. You cut it. You cut all the head of the cables. Now, after finish everything, you have to clean all your devices, all the equipment. Remove dust without putting down the equipment. You use first the rag to clean the external. Use the brush to clean the rectifiers. When finished cleaning the rectifier, you can use the same rag to clean the external.
Here, right.
The external body.
Here.
everywhere, even the batteries. On the ODF, you use the same rack to clean the external body on the ODF. But on our equipment, you can use the brush to clean. You can use even the air blower to blow it and remove all the dust. When finished, you can dry clean the floor. You dry clean and make sure everything is okay and well done.